Hello everyone, in this tutorial I'm going to show you how to use Real-Time Studio to create a Petri net and then to generate a stasis space. So let's go for the tool. It's here, so I just double click on this one, close the About box, maximize the window. Then what I will do, I will create a new Petri net. So I press on this button here for new, or you can do it from the file menu. We press this one, we get this dialog box, and here it proposes to us many types of Petri nets. And the one I'm going to be using is Interpreted Time Petri Nets. For the other types, it's not yet working, so I have just Interpreted Time Petri Net, which is working, and Hybrid Functional Petri Net, which is working. For the others, they are not yet working. So we're going to select this one, this type of project. OK. Now I have my project. It's an empty project, and the system description is empty too. Now to create a new Petri net or new component in the project, I will have to press this button. Press, and it's going to add a new Petri net. This is my Petri net here. Its name is ITPN1, but I can change it. So I would call it producer consumer something. So I just press again, wait a little bit, and then I can change the name. So I call it prod consumer for producer consume. So in this panel, I can construct my Petri net by using these buttons here. So the first one is used to move the components of Petri net. This one is for drawing, this one for erasing, selection, zoom out, zoom in, stretch horizontally, stretch vertically, stretch both vertically and horizontally, display the nodes on a circle, display them as a tree. This is to control the grid, which you can see here. We have a grid here. This is to cluster nodes. I'm going to be maybe speaking about it later on. This is if you want to, when you press the button on the panel here, you get a place, or you can select this one to get a transition or to get an annotation. This one is to flip or to rotate a transition. This one is for state space generation. This one is for verification of properties, timed properties, and this one for simulating the Petri net. So let's start by constructing the Petri net. So I press this button to say that whenever I press a button on the panel here, I get a place. And then I press this button to say that I'm going to be drawing. So when I press a button, I get a place. Now, if you go and click on this place here and you drag, you will start drawing the link, and if you release, what comes after a place, it's transition. If you release, you get a transition. If you start from this one and you drag, then you release, you get another place, and so forth. You can draw. Now for place here, you can see the attribute viewer or the properties for the place, and you can like modify them, and you can like play with these things if you want to. So here for the name of the place, as you can see, it's P0. I can rename it to make it P1 or whatever. You have to double click here to get access to the editing. For the shape of the place, you can change it as an oval, rectangle if you want, or triangle. It's up to you. So I'm going to leave it as the default one. You can control the height and the width if you want. You can play with these. And also the color, you can change the inside color, or you can change the border also. For the number of tokens in the place here, we have 0, but you can change them. You can, for example, 4 tokens. If you exceed, I think 6 tokens, like 7, you will get a number displayed instead. So let's leave it as 1 token here. For a transition, it has attributes. Also, you can play with the color, the size of everything. It has a time, the firing interval, which in this case is from 0 to infinity, but you can change it if you want. And you have other properties which are going to be used later on in more sophisticated type of Petri nets. Actually, it's what is called the Interpreted Petri Nets. We can set a guard, which is a condition, or we can even like have an update on variables. So for now, I'm going to be constructing a consumer or producer-consumer model. So we're going to be using this place. So I will press this one to move the places. So this is my place. It represents the producer. This place, this transition is going to represent the production operation. I will just rotate it to, I will have to press this one to rotate it. This one would represent the buffer where the production goes. And from here, if I stretch from here, I draw another place, a transition. So I will just flip it. And from here, I will just click and drag. And then when I release, I will get another node. And here I will draw another node to this transition here. Another node from here to here. Okay, just by clicking and dragging and releasing, everything is going to be performed. So I will be putting a token here. Double click. One, we have token. This is going to be the producer. I will name this place producer. So click here, come here, double click, prod. Sorry, so it's producer. What I can do instead of coming here, I can actually click on this thing and change it directly. Here it's consumer. So the way I do it, I need to be in this mode, moving mode, then I can like move these labels if I want to, and even like edit them. If you double click, you will edit them. Okay, then what we do, we're going to be using some control on this buffer here to have its size not increase to infinity. So I will select place, then I will go to the drawing mode. When I click, I will get a place, and I will have it to have like 5 tokens. And then whenever you produce, you need to consume a token from here also. And when you consume, you return the token here. So this place is going to be like a controller for the buffer not to exceed 5 messages if you want to. And so that's it. This is a model for producer-consumer. I can put a label, add a label to write it's producer-consumer. So what I need to do is to click on this one. And whenever I click again, I will get a label. I can go inside and type producer-consumer. Producer-consumer model. I need just to increase a little bit the size of this annotation if I want to. Model. Actually, this annotation is for nothing. It's just as a comment inside the model. And then what I can do from this model, I can generate the state space. If I click on this button, I can select one of these many types of state spaces. The first one is a state space that verifies LTL properties using the bounds, also, or using clock domain, or if you want, we can also generate a model that verifies CTL properties. So let's go for LTL properties. We don't need any optimization here. And then if we press this one, we get the state space. These are some statistics, and this is the graph. That's the graph. Now, if you go to the graph here or the state space, you can click on these elements, and you can see the attributes. You can visualize, for example, the equations or the interval, the time interval for each one of the transitions. Let's display the state. So instead of displaying the equation, I will display the state. In the state, what do we see? We see the different values for the tokens, like producer is 1, P1 is 0, and consumer is 1, and P3 is equal to 5. Like these are the different constituents for this Petri net here. So I can go to each one of these states and check this checkbox to display the state. Then what we can do also is to simulate the Petri net if we want to. So here I have my Petri net. I press this button. And I'm going to be using this characterization for the states. And then here in this, I click here just to fit the Petri net within this panel here. Then here we are at the first state, and in this first state, when you click it, this is going to be this is fireable, okay, which is in green here. This transition is fireable. So if you want, you can fire it and you move to another state. Now in this state here, you have two transitions which can be fired, and they are in green here, and you can select either one. So let's select this one here. You fire it, and it gets back to the previous state. Now we're going to be firing this one. Okay, we go here, then we fire another one, and you can keep firing. And in this state here, I will select this transition to go back up and so forth. So you can simulate, you can like trace the firing of the transitions. You can revert to any state, and you can just pick any one of the transitions. This is how we simulate the Petri nets in this tool. So now if we want to revert back to the normal Petri net, get out of the simulation, you click this one. So that's it for this tutorial. Next time I'm going to be showing how to verify time properties. Thank you for watching.